now we will actually create our own model. Yeah, don't be afraid. It's not that bad as it looks like. I know there are some equations. So now I want to show you on a model how easy to use the object-oriented modeling approach is. And I want to compare directly with the signal flow-based modeling. So as you can see here, we have this car, and this car, the movement of the car is created by 4 forces: the brake force, the drive force, the drag force, and the rolling resistance force. We could see this as 4 components. This equation has 4 components. So yeah, 4 components. So we just start with the modeling. Look, the first is we have a driving force, a force that makes the car moving forward. So I just want to show you how fast this modeling flow is using signal flow-based components and object-oriented components. Since there are 4 different components, we need, of course, the sum block with 4 inputs, of course. Because we have 4 forces, means 4 inputs for our vehicle dynamics, of course. I decided that we choose just a very simple model everyone can handle, because, yeah, it's just, I think easy models make fun and bring the feeling of success. So this is the first part. What we have here will be the drive torque, our first force. So then we have the brake force, which is this here. Since I know the names of all the blocks I use, or let's say mostly, I just searched for the names. You can also go into these Activate library here and look for your actual block you want to have, like drag in the gain, or look for multiplication, a product. This is the round product here. So we just connect this. Whoops. We can click this and click this, and there will be a connection made if we push the shift button on your keyboard. So let's take a look again. Divided by R. So R. And better. Let's do it the easy way. So this is the drive torque, and this is the brake force. So what can we do now? We can say we want to have a torque. Now I want to show you those both ideas in Modelica. So that's basically our torque. This is this component, and now we just need a brake, which is this simple component here. Can connect both. So you see we have more than, I think, 5 blocks here already, and we just need 2 blocks of Modelica here. So as you can see, if you know Modelica, you can model much faster. And yeah, just faster and more intuitive. It's a very nice approach. So here we have the rolling friction. This is just a constant. I will declare the variables soon. Just give me a second. I already have, of course, also the finished model if there will not be so much time left. But this is also very important what I want to show you here. This is going to be the rolling resistance. The rolling resistance, which is a friction in Modelica. You see, this is a friction. But other than this component here, this is a translational movement and this is a rotational movement. So what do we need? We need a component that makes a rotational movement to a translational movement. So we look at mechanics, go to rotational, go to components, and look, what do we need? Okay, an ideal rolling wheel. So a wheel makes, obviously, a rotational movement to a translational movement. So now we have this and this. So this is our friction on the ground. This is the rolling resistance here. This is this. This will be this part of the components. So 4 forces, 1, 2, 3, 1, 2, and 3, and one more will be depending on the actual speed. We have a differential equation of second order. That means the first integration I always try to use German, but sometimes German is not working. Yeah, easy integral, not integration, it's integral. So yeah, this and this, we just make a flip, connect it here, connect it here. So this is how the model would look like without post-processing, without scopes in signal flow-based modeling. And this is almost how this model would look like in component-based modeling. This here is going to be beta signal. Beta is between 0 and 1, the brake signal. So what else do we need? We have the torque, which is this. We have the brake, which is this. We have a wheel, which makes from rotator to translator, and we have the friction. But now we also need a drag force. Modelica standard library doesn't have a drag force, but we can create a custom component within Activate using the Modelica custom component. Yeah, custom component. Yeah. Here we can name our flanges on the left and on the right for the Modelica component. I always like to give it the standard name flange A, flange A, flange B, which is standard in Modelica. Then we can add some parameters such as CV value, air density, for example, and yeah, I don't. It's just for presenting. I will show you the finished model right after this. So imagine this is going to be our drag force, and you can just put in here the Modelica code. I think this is for many of you the first time ever to see an actual Modelica code. I would just copy that from the already finished model, just for presentation. So this is here a Modelica code. This kind of code is in every Modelica component. You have your parameters, you have your connections, flange A, flange B, and then here's the actual equation. And here is the implicit equation of this component. So that's it, basically. That's it. And now we can say, oh, this is one superblock here. This should not be like this. This should be not here. So this is one superblock, and that's the other. So now we have a signal flow based model and a signal flow based model. So, but now I will show you the finished model with, because putting the parameters and do the post-processing and make the thing look good takes a bit of time. So this is the actual finished model here with a finished Modelica component with a mass. Of course, the mass is an important component too. A vehicle has a mass. So yeah, we have this and we have this. So both approaches have advantages and disadvantages. You obviously cannot see poles and zeros and the whole system theory in your Modelica component model, whereas you could see it as a very experienced engineer in your signal flow based model. So let's take a look and press simulate. And now we are compiling simulation. Oh, and plot on my other screen. So you can see it's exactly the same results with two different ideas of modeling. Yeah. What else could I show you? This is the whole post-processing I showed you already.